Good morning, everyone. It's a Wednesday morning and hump day. Here we go and off and running. Today, continuing working on the mini golf game. And yesterday, we were able to aim the shot, and we were also able to. The day before, we got it to where you could decide how hard to hit the ball and everything else. Well, today we're going to start working on some of the avatar animation and getting the avatar in position to strike the ball. So we're going to put all those kind of pieces together based on wherever the ball's at the time. So that's where we're at. That's where we're jumping in and kind of getting the sequencing going so that the flow of the game kind of falls into place. So a couple different things that we'll be working on. Yeah, we'll get it all together. So off we go. Back to the code page, and just so you can see what we've already done, I'm going to shrink that a little bit on this side just so that we get a little bit more room on our screen. Okay, let's just refresh the page just so that you can see exactly where we are. Good morning. Okay. Okay, so the first thing we have is when I click down here in the T area, it drops a ball, and basically you can aim the ball here, so you can decide which direction you want to hit it. And you can also set the power level here, and when you push hit, boom, there goes the ball. So now we need to make the animations match that so that we're actually playing the game along with that. I missed. No, I'm just kidding. Oh no. Okay, so that's kind of where we're at. That's what we're working on, and we'll see what we can do here. Refresh that page. Now, one of the things I want to do is when I click on the T box, I need to, if your guy is even, your avatar is even close to it, I need to make your avatar walk over to a position over here and turn towards the club, and we'll add some animations afterwards so that they actually get ready and then actually strike the ball and stuff. So basically we're going to get the character to stand right over here somewhere, but we need to determine that dynamically so that wherever the ball is and whatever direction you're aiming, the person is, or the avatar is kind of in line with that, perpendicular to where you're going to aim, standing there ready to hit the ball. So let's see what we can do here. Let's see the best way to do this. We may even create a different camera view. That might be some cool part to do it so that we have a unique camera view of what we want it to do. That way you can see the direction you're going to hit the ball and be able to, we'll play around with that when we get there. First, we need to make it where we figure out where does he need to stand, which is going to be somewhere in this area over here based on where that's at. So to start out, when I click this button on the T, I want to, I'm going to create a box just because if I create a box, then we can calculate where it stands, what direction it's facing, and kind of get it in place. So for now, I'm going to create a box, and we're going to work on where it's positioned so that we can get it all worked out. Okay, this is the easiest way that I can think of to do this. I should say, instead of avatar position, just because this is a golf game, we're going to call it golf position. just so we know where the person's supposed to stand and orientation of what direction they stand, the whole bit. Parent is the main parent, which will get us in real time where it should be. Scaling 1 to 1 to 1. Position should be, for now, 0, 0, 0. Instead of parenting it on that, well, we don't want to parent on the drop box. We don't want to parent on the ball because the ball's going to spin. Yeah. Why is... Oh, that's... Okay, that's a hard-coded piece. That's no big deal. Okay, so we're going to start by creating a box. Right now, I just want to see the box show up at 000. Let's go 5 high just so that it's on the flagpole someplace and we see divisions or subdivisions don't mean much when you have a box. Let's just create that so that we can see what it is. We will call that, or instead of Dropbox, that'll be, oh good. Instead of Dropbox, we're going to call this, same thing we called it here, golf position. We're going to be moving that around based on where the ball is, and I just kind of want to get it on the screen first, then we'll start calculating where it should be and make it work. We're going to check to see if it already exists because I don't want to recreate it if it already exists. Get mesh by ID, and it'll be called golf position. If the golf position already exists, then the only thing we have to do is move it in accordance to the ball. So we're going to check to see if it exists. If it doesn't exist, golf position equals null. Then we're going to do this code right here, which creates it. And then after that, we're going to find out two things. First thing is we're going to get the absolute position of the ball in the world view. So if we get world position, and if I set that to golf ball, which by here it's already created no matter what. So we're going to do that, and we're going to set the box, this golf position here, to golf position dot position dot absolute position x equals absolute position dot x. That'll be the golf ball's position x and the golf ball's position z. And let's see if it puts the box there. Let's go that far right now, and then we'll start working on what else it needs to do to make it move to the right place. Once we get that position, then we'll have our avatar walk over to that position, which if you're working with me a couple days ago, we made that our end of last week. We did that same process with walking in front of a chair so that we could sit down. We're going to get this point, and then we're going to use that same function to tell it to walk to the place where he's going to be, and then we'll have to tell him what direction to rotate to, and some fun stuff there. But we'll get those pieces in place. Okay, let's see. Oh yeah. So all we have to do to start this sequence is to click here, and we do not have the ball. Oh, I know why. We made it hidden. Right now I'm going to say color just so that it shows. It doesn't need to show after we're done, but right now I definitely want to see.
Did you shut the printer off?
The cable is detached from the printer. It's not. The box, Karen. The box up on top there. Sorry.
Mm-hmm.
The box on top, you have to bring it down to the edge there, and then there's a cable that plugs into the back of it, which is one of those network cables. Yeah.
I don't know why you're doing that.
You were looking for it. Okay.
I don't know why it's on hold, but okay.
Because
Okay.
I'm not going to, yeah.
Okay.
Oh, hang on just a second. I'll be right back in about 1 minute. Okay, I'm back. I'm back. Okay, so what we're doing, okay, notice there's the box that I just created, and it is in the position of the golf ball in the X and Z axis. I didn't bother with the Y axis, mainly because at the time the golf ball was being dropped in front of the putter, and so it technically was up here before it was down there. So the next thing we need to do is now I need to offset that by some degrees over this direction, but we won't know that. Let's see. We need to tell it to aim. When I start to aim, it grabs that line, and then I can use that as a reference of where this button should be. So we need to trigger at least this function. Aim, where it creates the aim line and starts that function. So on value observable, which in this case would be 0. Yeah, it starts out at 0. So then let me take this right here. We're not going to use this whole function, so I'm not going to worry about like creating this whole function again. It's all the way to there. What I want to do is I'm going to streamline this to actually, when it creates, yeah, okay, that's hit golf ball, pick the club up. Nope. Where'd I go? Just scrolled right past it. Here it is. Okay, so I'm getting the golf position. I can't get the golf position unless I have that piece in place. We need to... Okay. That's the ball drop. This is the golf position. We can't do the position until this piece is in place, so I'm going to insert this code here. And we need this aiming line in place so that we can do the rest of the stuff. So we don't have to worry about this alignment so much because it's actually going to be angle 0. So angle times direction. Direction would be, oh, plus or minus there in that case. I'm trying to think if I can do this without having a value, angle equals value. Well, if it's 0, then angle direction is still 0, so I don't have to worry about direction of the angle offset from the current amount. So we should be able to angle equals 0 and get rid of all the rest of that stuff and all the rest of that stuff. And okay, so that gets this piece, and let's take the angle here. I'm just rearranging a couple things, turning this function into the new function that we need. Oops. Okay, we're looking to see if the mesh is there, and if it isn't, it creates it. And notice how we use cosine and sine of the direction to get the direction that we're going. Well, we're going to do the perpendicular to that, so we should be able to swap a couple values and get that correct amount based on, instead of sine and cosine, it's going to be probably negative cosine and positive sine. And we'll try it. We're going to find out. If it's in the right place, we'll get it right. If not, we'll have to figure out where to go with that. Aim line, it checks to see if it exists. It creates it if it's not there. It uses this absolute position, which I want to make sure I'm not, like, I keep using absolute position, spelling it the same way, but as long as I put var in front of it, it should be friendly each time. Based on this, what does it use the absolute position for? The aim line rotation. That's because I'm rotating it after the fact. I think when we first open this, we're not going to need these steps. Oh, okay, we've got... Let's do it this way, just so that we get the aim line. We want to set this mini golf direction. I think once we've set the mini golf direction, we can use that direction vector to determine where this stands based on these numbers, I believe. Yeah. Just thinking about where we're at here. Okay, so there's two pieces. We have the direction. We also know the rotation of the aim line, which is a good thing to know. We can use either one of those. Aim line will automatically exist, so we can pull the rotation of that here and work with it from there. Let me see if that turns on the aim line and if we get through that without any errors. I want to see if it aims properly to the hole, because that's what it technically should do. And if we click here, yes, we do have the aim line. It's right to the hole. That's fine. It should follow the ball down, which we didn't do, but second you move it, no, it didn't recreate it. See, that's why I was worried about recreating it too early. Since it's not parented to the ball, actually, we can update that. If Now I'm just trying to think of how we want to do this. We need the line, but technically we don't even need to see it. We just need a starting position, then we can move them based on the other part afterwards. If we get this direction right here set, that's really what we need to calculate. Once the direction's set, we can use that direction and then we can update the position of Y when we try to move it. That's actually, okay, I think that will work better. What I'll do is I'm actually going to turn off the visibility of this line, and then when you go to move it, we will take this up. Since we're doing these steps up here in the function, aim line equals that, and notice how I set this here. The golf ball, I'm going to get the golf ball position if it doesn't, yeah. I'm going to move that up so that we have the golf ball position at all times anyway. We'll name that golf ball position just so that we don't have the same name on everything. And that will be here, here, and here, and these three, and that will do that. If it's null, then we get, it creates it. Otherwise, we're going to set position Y. That'll move the position, and we'll get it back down to where the ball is the second you go to view it. We're also going to set aim line is visible equals true. I'm not going to set it to false right now, but we're going to, in the long run, that is going to be the case. We'll create the line here so that you have it already. And what it's going to do is that way we have the line, we know the direction to target. We can use it to create, to get the guy to walk over to the right place, which is the whole intention of this part. But we don't want to show him it not on the ball. But the second you try to aim it, it's going to show it anyway. So that'll give you it as you aim. Okay, so let's see. We have. I'm going to set aim line equals false here, and for now, I'm going to just tell it to remark that out so that we remember to put it back in place when we're ready to. Now from there, we should be able to change this golf position based on a point that is parallel to or perpendicular to this direction that we're currently traveling. Okay. That's going to be 0, 0, 0. You know, we could take the rotation, move it back minus 90 degrees, and then calculate out a certain number of distance from that line. That will work. So let's do just that. If we take aim line rotation, does this distance down? Okay. We will do it right here. Angle equals rotation. We're going to say get degrees of that minus 90. That should give us the right angle. And then from there, we have to figure out mathematically which one we need. It is going to be a position based on sine and cosine, a certain distance from that point. I'm remembering some math as I go. Okay, so let's see. Let me think this through. Let me think this through on a search. Okay. Point. Find point. Distance at angle. Okay, it's going to be, I already know what it's going to be. It's going to be a sine or cosine. I just always like, okay. For example, sine 160 degrees is that, divide the height. Okay, that's distance at an angle. I know. I don't want to watch a ton of videos. I just want a quick answer. Okay. Here's the equations for that. X distance and sine. There we go. We could end up being 90 degrees off based on our plus and minus of what we did on our last piece. And this is the angle distance from origin. You want position at a distance. We have to add those particular pieces to it. Okay, so that's the formula we're looking for. We'll put that here. And we'll make these pretty afterwards. I want to see it work. And where X is absolute position X, because that's our new origin. And then absolute position Z is our other origin, which is the golf ball. And then we want this angle, cosine distance, where distance will, I'm going to say it here, because we're going to move around the distance as we figure this out. like distance equals, we're going to say 1 for now just to get it going the right direction. And I like shortening the names. We don't need the whole name spelled out. Distance times cosine. And like I said before, I think we're going to be, because of the left-handed coordinate system, we're probably going to be 90 degrees off or something off with one of these two values, the same way we did on the other calculations earlier. We had to adjust them. So this would be position X, and this will be position Y, or well, actually it'll be position Z. Got to make sure we know we're in the XZ coordinate system. Y is straight up and down. Then we take this position and we make it that. And position Z, we make it here. And now we're going to end up someplace next to where we were working before. So it should be off 1 unit from where we are, which, we'll see which direction that is. It's going to be from where the ball drops. So it's either going to be this way, or that way when I click this. And it didn't create it at all. COS is not defined. Oh, forgot. It's not just cosine, it's math.cosine and math.sine. Forgot to tell it that part. There we go. And let's see what that does. Okay, our guy, get him in here. There he loads. Okay, and like I thought, it is going the wrong direction because we need it to go this way, and then we'll also decide how far we need it to go. That's not a problem. We can do that. First of all, I think it was, we did it up here. It was a negative sign to get that rotation to the right place. So I'm going to try negative sign here and see if that doesn't get us to the right place. Like I said, dealing with a left-handed coordinate system instead of right-handed, and that's all fine. You get used to it after a while. Or you never get used to it and you do like I do and stumble through it every time you need to recalculate it. But it's not a big deal. It's the way it is. Okay, that's going that direction now. That's the wrong one. We need it to be the cosine to go the negative direction. I knew it'd be something like that. Okay, and yes, actually using face only mama could love. I love your name. That's pretty cool. But yes, WebGL through Babylon. I use Babylon.js as the engine behind this, and so we're basically using that engine, which gives us WebGL with a lot of extra functions. I built a layer on top of it so that we can turn Babylon into something more like WordPress, where you actually build components and you can add and drop them into scenes. So you can actually create plugins, or you can create scenes. You can create, let's say, a building, but drop it into many different scenes. Or then I did all kinds of cool stuff, like if you walk towards it, it loads, and if you walk away, it unloads. It can even host them on different servers, so the building can be on one server over here, or the game can be on a server over here, yet I drop it in my scene, and now all of a sudden it works in my scene. So I've done all kinds of cool stuff with that, and that's where we are. Yeah, so we're actually creating things like that, and in this case, what I'm doing is setting this up so that we can play the game. Right now, what I have in place is we can aim the direction, as you can see here, and we can also set how hard you want to hit the ball, and when you click hit, it does fire the ball off. So now we're getting the avatar to catch up with all the different animation that's going on. So we can walk him to the position and address the ball, and then go ahead and make him move to that point, and then we're going to work on the animations to actually do the golf swing and everything with him. So we'll be adding animations to our character. We'll be doing all kinds of cool stuff here shortly. And let's see, in this case, I'm just trying to figure out what position, and of course that went the wrong direction again. I think because I moved it 90 degrees off here and now I'm trying to move it a certain degrees off here, I think, oh, the angle, yeah, the angle cosine, absolute position. Let me try this from 0, 0, 0 and make sure we're going the right direction first. So I'm going to get rid of this part of the equation just for the moment. Like I said, I always screw up because of the left-handed coordinate system. I need to make sure I'm going the right direction. But yeah, definitely. So we're actually creating plugins, and we're actually creating all kinds of cool stuff where you can actually just drag and drop and add a different functionality. That way, if you're a programmer and you decide, hey, I'm great at making cars, you can make a plugin. Let's say you give somebody a Jeep for free, and then if they want to have an avatar get in the passenger seat, or if they want to drive the Ferrari instead, or whatever, then they can pay you, and you can actually make money and unlock extra features, or even subscriptions, whatever you want to do with your plugins and stuff. But it's open source. I dropped the code out there of the whole site that I did, the whole interface, which, as I said, all this kind of stuff here, all this stuff is part of my interface, which takes on the appearance of like a WordPress type program, but using the Babylon engine behind it. So we actually are able to create different things, add them in here, drop in, add the games, add the different functionality, and you're going to be able to basically just drag and drop and put these different, holes in your games. You can take it by one hole at a time, or you can actually play the whole game, whatever it is. We can do all kinds of different stuff with it. So ends up being kind of cool. But yeah. And just so you know, if you follow me, then one of the things I do is anybody that follows me, if you need something, you're the ones I take care of first. So if you say, hey, I'm building this plugin and this one thing doesn't work, or I need this added to the main program or something to make it all work, then I pay attention to you first. I give you first billing on whatever my priorities are. So I'll help you make your plugins work, whatever it takes. And basically, I just want to see this be successful and get it out there for everybody. So dropped it out there open source, and the link is down below if you want to host your own site using it. And I do regular updates on it. I'm here almost every day programming and creating things for it. Fixing stuff, whatever's needed on it. I take care of everything. So, yeah, just a little incentive to follow. Okay, so here we go. And what I'm working on right now is, I need to get a position for the guy. So based on where the ball is and where the direction you're aiming, I want to figure out... Babylon is actually pretty easy. If you've done any programming with JavaScript or any game programming at all, even if you haven't, the reason I picked Babylon is because it has great documentation. It actually takes you through a bunch of tutorials that walk you through the paces. But the cool part is because I use that engine, you can actually code things directly for Babylon and drop them right into scenes. The other thing you can do is I set this up so you can build things in Blender and then export as Babylon because they have an exporter, and then drop them right in the scenes. So for example, in this particular scene, the flag over here, I created that in Blender, I added the animation and dropped it right in the scene, turned on the animation using my program, and we're up and running with that in no time. So this is kind of like the assembly ground and the loader that I created. As you're walking, you load things. In fact, watch this. If I walk backwards, what happens is at a certain distance, it disappears. Now I can set that distance, but look what I have. What I created is these zones. It's invisible boxes basically, and notice it is a box. You can see the edges over on the sides, but what happens is as you walk closer to an object, it tells it I'm near it and I need to load it now. And that's how we control what's loaded in the program at any one time. So opposed to when you create a game, normally you try to create a level and you try to put in whatever you can and everything else to make it not too big, not too bulky, not too many polygons, the whole thing for efficiency. But then you play the game, but you're limited by that, basically size of a bucket of what the computer can hold. But the difference is, in this case, is you can actually create bigger scenes because I'm controlling what gets added or removed to the scene at any one time. My code does. And then basically all you have to do is you can custom design when you want these boxes to appear, or put them inside of some that I have set for you already. But the idea is we can load on the fly, which means it's kind of like walking on a treadmill. It's going to keep on going as you're going. It's going to load things as you get closer and unload things as you get farther away. But the road never ends because you can keep on going. You can always load more by walking farther and unload things by walking farther away from others. So it's more of a balancing trick of don't put too many things in one place instead of worrying about what the actual level has as a whole. Then I divided it into 3 main parts. We have the communities, which are your scenes. We have the buildings, which in this case, the building happens to be a golf hole, but you can create a building as a physical building or an area where you're going to play a game or anything you want it to be. It could be a statue. It could be anything you want it to be. And then things are different items that you put into buildings and communities. For example, I can put an avatar, a chair, a vehicle. I could put anything, furniture and trees and anything that makes the scene come together. You can make bridges. You can make all kinds of things, to drop into scenes. But the dynamic is you can create a thing once and then put it many times into a building or a community. Then you can create buildings and drop them multiple times into a community. So it's the relationship of the instancing so that you can create it once and put it in many communities. For example, if I do a 3D store for shopping, I can put one 3D store as a building, and then I can add it to hundreds of communities, which means drop it in different scenes. It's like having a Starbucks in every city. You can even put it on multiple times in one city, So this is kind of like the building blocks for creating internet cities. That's what I did. And I dropped it out there open source so everybody can do it. And we can all create plugins and stuff and work on making some, money on our plugins. I want to make money for developers. I gave you an environment that you can actually create 3D shopping stores for customers. So you can actually build sites for businesses. You can also build games. Think of it this way. Amazon and Walmart and all these others are working on creating their stores in 3D right now. Well, are you going to walk around a store just to click on a product and read about it on the shelf? Or do you want to play a miniature golf game and I happen to see a t-shirt shop next door and walk inside and buy a t-shirt and then keep playing the game? That's the difference. I'm putting the businesses right into the games so we can blur the lines and create some fun cities to play in. Yeah, definitely. That's almost what they do, huh? 2 Starbucks right next to each other? Yeah, definitely. Well, like I said, that's the concept. That's what I'm working on. And I'm right now, I can tell you this also. I'm looking for people that want to join me and help me build this and also host a site or whatever so that we can connect them up. And, we're going to keep on building it. We're going to create some cool games. Awesome. Thank you for following. I love it. In fact, you know what? I'm going to do something special. I'm going to make you a VIP because I got that available. So and that way, you're a VIP in here. Oh, what did I say? Did I type your name wrong? It says unable to add VIP. What's going on? If it doesn't do it now, I'll figure it out. Ah, there we go. Okay, it's my typing. Okay, yeah, you're a VIP. Hey, programmer works for me. But yeah, you're one of us. We're going to build this stuff. We're going to connect up different sites. I have some servers on the internet, so if we need a place to host it, we can definitely work out something there. Otherwise, we can, like I said, you can download the code. You can follow along with me if you have questions. Shout out, answer. I'll answer questions as we go. I've taught computer programming. I've taught algebra. I've taught all kinds of fun stuff, and so I like teaching. I enjoy doing it, and like I said, I'm making this stuff all work. So whatever it takes. In the program right now, if you don't log in, you get 2 choices. There's a male and female robot-ish looking avatars, and you can color them and add whatever animations you want to them. And then if you create a login in the program, then it allows you to actually it lets you pick from 10 different avatars, and you get a lot more choices. We're going to make this, one of my goals is to get this to a point where we can do something like Ready Player One with it. That would be really cool to set up a scene and have Ready Player One type functionality and gaming going on. But we're not there yet. We've got some efficiency things to work on. Plus, I'm going to set it up where we can actually take our avatar when you do it. Programmer. There you go. That works too. That works too. We're all very intelligent programmers. Yes, I like that one. But yeah, so basically that's the idea. I want to be able to create this stuff. I want to be able to put it all together where we can have, like, let's say you build a custom avatar for yourself. You're going to be able to upload it and use it in any scene you go to on any server, because we're going to connect them all on the internet and turn this into the 3D internet with all these hosted from kind of a standard of how we're going to host them. So that's why I went open source, was so that we can all use the same standard of how we build things so that it works in everywhere. And that's kind of the way we're going. So yeah, that's where we are. Okay, so back to this. When I click this, I want to see what direction that's going. Right now it is before the flagpole on that side of it. Okay. Another thing I can do is I won't have to run over here every time. If I set starting position, click the button, now he'll start here every time and I can see what direction it's working. If I take this without, okay, the angle, that's with the negative. Let's see. Let's see where this naturally comes up as. Oh, I forgot I got to click the other button to make it go around. Okay, and let's see. Okay, when I click this, the box should show up, and by default, it is not centered on the flag. That's interesting. I would have assumed that it was going to be centered on the flag. Oh, distance is 1. Well, that should nullify it. Okay, my brain is not wrapping around this right now. Angle is... Let's find out what the angle is here, because that'll kind of tell us a little bit of the math too. Log will get it to our console log, and angle equals angle. Okay, and then I want to find out what position we have. We're going to find out this every time we do it, just so that we have some type of data to work with. See what it's doing. Copy that. There. Let's see what it does. Let's, you know what, I'm going to save it in a position where I can see that. Options and settings, set starting position, there we go. And now I'll always have that there. Okay, so those values are a little bit off of 0 in 2 different directions in the positive direction. That's interesting. At angle equals 90. Well, it is 90 degrees. Okay. I didn't mess everything up by moving. No, because I'm not calculating based on the guy. Okay. Need to see, is it off-centered? Yes, it is. Okay. So if it's off-centered 2 different directions right now, I think, therefore I am. No. I'm wondering, the rotation of that should be the angle we're going. If we subtract 90 degrees off of it, we should get this. which means that was 180 degrees. Now we're at 0. Now we should be able to... Yeah, I know. I get screwed up on this like every single time, and I taught algebra, I taught math, I've done geometry, but for some reason my head doesn't grasp this. When if I go distance 1 at an angle of 90 degrees, okay, I understand why it's off-centered, that's all good, but wouldn't 90 degrees, if this is a perfect 90 degrees and that was 0, 0, wouldn't it be one direction off of that without... shouldn't it be like a positive 1 or a negative 1 for the angle? That's what's throwing me off. I would expect it to be a positive 1 or a negative 1 or a 0. I wouldn't at a 90 degree position. It shouldn't be halfway anything, because that would be like a 45 degree. But if it was 45 degrees off of 0, then our x and y value would be equal, and they're not. So that's like 1/3. That would have been like a 60 degree angle. That's why I'm saying it doesn't make sense to me mathematically, and so it's kind of throwing me off at the moment. So we're going to do a check here and see. I want to see, well, actually I know those values because it is the distance, which is a 1, times those. So I do know those. That is going to be those same things. That's the angle. Is the angle supposed to be in radians? No, cosine of an angle is cosine of an angle. It's not cosine of the radians of the angle. That's why it throws me off every single time I do this. For some reason, it never does what I predict. I would think 1 degree off of when it should be either straight this way, straight this way, straight that way, or straight this way based on that line right there. What am I missing? What am I missing? Okay, let's find out if we go, the angle is the angle of the line, and then we'll use the cosine and sine to step off of it. Let's see what that does. Okay, so from here, now notice it's more my direction, but that's still not right. That's still not right. See, it's acting like the angle isn't straight this direction, but the angle is 180 degrees, and it's putting it out this direction. From 0, 0, 0, it is stepping it off that way. Just doesn't make sense to me. Just doesn't make sense. Watch this. I'm gonna prove my point. For x equals 0 and x less than 360, x plus, and I'm going to tell it to say and let's see, cosine equals cosine of plus x equals cosine x. Okay, we're going to do those, and then we're going to do sine, and I'm just going to prove my point because it's confusing me. We should be hitting at certain degrees, we should be hitting exactly at a 0, a 1, a negative 1. Now, what did I mess up? I typed that wrong. I know I did. Okay. Can't even do a for loop. My brain is thinking of something else. Okay. Why can't I do a for loop? I've done these like millions of times. Why can't I do it? What am I doing wrong? My brain is thinking of one thing while I'm doing another, and no, what did I do wrong? I'm just spitting out the x values of cosine and sine just because there's a certain thing I'm trying to do, and for whatever reason it's not giving me the values I'd expect. I'm just checking the math function to see what the heck I'm doing. Yeah. And what did I do wrong? 4 var equals I, blah, 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 blah. Why is the for loop, that's exactly what I typed over here. Did I type something wrong? I know. Yeah. Okay. And I have no idea what I did wrong here. That should have spit out something. Our x equals 0, x less than that, x plus plus. Why is that not... Does it not like me using x? Wouldn't understand why. What did the error give me? Unexpected syntax error, expected token 4. I've got a math issue here that's kicking my butt, and I don't know why, but I'm trying to figure out why this all of a sudden has an issue. Did I type something wrong? X less than 360, x plus plus. I don't see anything wrong with my... Unexpected token 4. Okay. Which means... Oh, there it is. Right there. Didn't finish this statement. Where'd it go? Okay, that was what it was. Sorry. Okay. I just want to see for a second here. Yes. Basically, the user can walk anywhere near there. When they click it, I need to make them move over to where they need to and address the ball so that then they can just swing and stuff, or, you know, aim and then swing. So it's kind of a way, because right now, if you had to go up into here, and if I had to go, okay, I'm going to hit the ball, and I have to walk up here and then kind of like backwards, forwards, left, right, and everything else to try to get it right while I'm trying to aim, makes it a little bit more difficult. But if I can come over here and you walk up and you say, oh, I want to play, and it just has a little sign that says click here to begin, and when you click it, your guy walks up into position and takes it ready to hit the ball, has the club in hand and everything else, it'll make it a little bit easier for the flow. Then as you're moving, you can walk closer to it, but when you walk close enough to the ball, if you click on the ball, then he'll line up on the ball again, ready to aim. So I'm kind of taking control of the avatar to help move you to position, only so that it becomes easier for them to interact with the game. Just kind of like, you know, just getting them ready to putt, and then they can actually aim, click the button, and it'll putt. So we're assisting. It's not that we're taking, you know, we're not going to completely, if they decide to walk away, it's going to move on to whatever they're doing next and walk away. But this will be a way that we can actually get them to play the game and be lined up without making it too difficult to line up. Then, as they're aiming, like if they move this, what we'll do is we'll have him move based on the aiming. We'll have him kind of rotate or move his position to do it and everything. Yeah, you got that. And what I noticed, okay, look over here. What we've got is, first of all, okay, if we look at cosine first, which is the first half of this, I know when we're doing 360 degrees. So, first of all, angle, okay, let's start with cosine 0 equals 1. See, if it's at 0 degrees, it should be 1, and if it's at 90 degrees, let's check 90 degrees here. 90 degrees should be, oh, it's not 0. It should have been 0. I think, no, it didn't go to 0. I would have thought cosine 90 is a 0, and then let's see what cosine 180. Cosine 180 is, see that's what's throwing me off. That would not necessarily be right. Huh. Okay, and then cosine 360 should be back to 0. Can't be the only one who ever ran into this problem. See, I didn't go to 0. Okay, that's fine. Sine is 0. See, cosine 90 is 0. That's what I thought too. And that should make it go directly 90 degrees from the aiming part. But what's happened is when I go cosine 90 degrees, I'm getting 0.44, a negative 0.44. I agree with you. That's what I would expect, and that's why I thought the math would work. But because it did that, there's something, it's not getting the correct values. Okay, see, here we go. This question's already been answered. Oh, see, it does go in radians. Ah, see, that's the problem. Normally, math cosine, you do... there's where we're getting it wrong. Okay, so if I take that, that makes a lot of sense. If that's wrong, then of course that would be really wrong. The good news is I created a function that lets us get radians. We're going to check the math on this, and if that works, then that would help us get everything back into place. Yeah, you're right. Definitely. Okay, so if we convert that to radians, then that means I would be doing that here also, which now we should be getting the right position that we needed. And we can even add that position back in afterwards. But now we should be getting what we expect. Let's find out. Just double check. Yeah, I think so. I think we are on the right track. If I click on this, now I should be... Okay, I'm exactly... Let me find out. I think I'm in line with the flag, which is what I would expect. And yes, I'm one position, but now I'm in line with the flag. Yes, that's giving me what I expected finally. Okay, we're getting back on track. Okay, that was it. Thank you very much. Thank you. Okay, and let's see. And now the numbers are looking like they're supposed to. Because, of course, like you said, cosine 90 degrees should be 0, and I'm guessing it is. Cosine 0 is 1. Cosine 90. I know, I didn't have to do all these numbers in between here. Cosine 90 is 6. What? Oh, to the negative 17th. That is a rounded off 0 to at least many decimal places. I'm okay with that. that makes more sense than not. Okay, got it. Yay! Okay. Okay, now I can get rid of this little piece of code that spit all that out. You know, that's going to help me in about 10 different places that I already was working on before where I kept screwing that up. Now, of course, using the radians, which, if I would have noticed, that's radians. Ugh. Okay, let's say it's a Wednesday that's more like a Monday morning. There we go. That explains it. No. Now, if we offset by this position, and now we should be able to determine which direction we need to go. Based on this, the angle is this minus 90 because we're taking the angle to the flag and we're taking off 90 degrees so that we have a perpendicular mark to the target. And then we're going to travel out that direction a distance, which we haven't figured out how far we need to go for this avatar yet. But this should get us in the general position now, and let's see if that does what we think it does. Okay, going down here, and I'll probably move my avatar down there. Okay, and I'm okay with being 180 or that distance wrong. My It depends on where the angle is actually being calculated to which direction. Notice it went that direction, so we're going to give it the negative cosine like we had to do on the angle above. By reversing that, we should get it on the other side. We're going to save some time here also. Let me set starting position here. There we go, and okay, then when I click this, oh, we're still on that side of the ball. That one didn't do it. I have a feeling that's going forward or backwards, so it would need to be negative sign. And like I said, working with the coordinate system and then reversing it back to the other side. Yeah. Okay, and from here, now when I click it based on the line, there we are. And if I'm not mistaken, it didn't move it forward or backwards, which means we should be, yep, we're in line with the end of the target. Yay, we got the right direction. Okay, we're making progress. Now that we have that, I need this to be, let's go 6 distance back. And let's see where the box ends up. Clicking that. That's not too bad. If it ends up being a little bit off, we can still decide that distance. It's a variable, so we can work with that. But now that we know that position, the good news is we know with that box being at that position, we can now use that position and tell it to walk to that particular box. Get position of the golf ball. Huh? That isn't even being used at that point in time. That was the aim line. Hang on. Let's move this before this because that's the position of the golf ball, and make sure that we're working off the position of the golf ball, not the position of the line, because the line could actually be, well, no, it's the same place. It should be the same place because it's the origin of the line. Just going to double check and make sure that didn't just break it. Yeah, I know, using the same variable in multiple places, that's why it even worked at all. But let's see. Okay, we're still in good shape. And next, I wrote a function when I was working with putting somebody in a chair. And this function, it's walk to point, I think. No. Avatar walk to point. What did I call the darn function? You know what? I'm pretty good about... Oh, it might not be in this file. Nope, it isn't. Okay, in the core, scripts. Get our prime scripts out here. Oh, sorry, avatar scripts. And load avatar, I believe it was in here. Yeah, it is. Okay. This is where I did this stuff. Walk to position. Then I say avatar name, the mold to match, and then if you want to send a function that you want to execute once you get there. Cool stuff, huh? Okay, so we're going to go walk to position. In this case, before I was walking to the position and I was telling it to sit. For now, I'm going to remark that part out. That's what I was creating the walk to position for. But now I'm going to use it for other functions. So let's see if I go walk to position and avatar name and match. Let's put that into our other code. We're going to see how well I did on this. This, and we want it to be right here. Walk to position. We're going to pass, we don't even have to pass the two last values. Avatar name is, our own avatar is always named the same thing, and I can actually get that just so you can see where it's on the load avatar page. The avatar name is, I use it about 1,000,000 times on here. Here it is. This is the avatar name right here. Get back to my other page. So we're going to do avatar name. It's our instance with the words my avatar in front of it. And mold to match is going to be this golf position. It's going to look up the absolute values of that and walk the avatar over to that. And let's see if that does what we think it does. I was working on this for the chair, so I reserve the right to be wrong. Thank you. Okay. Let the avatar finish loading, and we have the avatar in place. And now when I click this, he's walking and he passed it up. Okay, this was something I was afraid of. What happens is I set the walk to happen while he's actually moving towards a position. And so what's happening is he's not turning sharp enough to catch that position. So basically... Now, see, he's missing the position. That's one reason why I was going to work with that. Yeah. Okay. We're close. We're not there. This function needs a little more help. What I could do... Okay. This was happening in a couple instances. I can tell you this. It's kind of funny. But basically, the avatar needs to kind of hit it pretty accurate to stop. And in this case, he missed it by a mile, which definitely made it not friendly. Okay, so we're going to work on this. It needs to be fixed for the other function anyway. I'm just moving this over so I can switch between my two files I'm working on without having to jump back and forth too far. So this is where I want to go. First thing I'm going to do is I'm going to validate the position that we're going to and then see if position is right down here. Okay. I could make it where we can rotate faster to the target so that we're not missing it by a mile. There's a couple adjustments along the way. As it's walking, see, this is getting its original rotation, and then this is adjusting it. Wait a minute. Okay. Just want to double check this one. Am I passing the... Yes, I'm passing the radians. I want to make sure. If I'm not dealing with the right thing there, that would be all kinds of weird stuff. We could get more sophisticated with checking the distance to the point so that we know how close he is to the distance, and we can let it rotate sharper angles at a closer distance. There's some adjustments we can do. Here we're telling it if I'm checking the distance. If distance is less than 2, then walk equals 0. And then if it's walk equals 0 and degree left, oh, I need to move this to here to make sure that we stop walking if we're that close. So if it got close enough, we're going to click on stop walking, and then we have to keep on rotating until we're there, though. Let's try that first. I know there's some adjustments as we go in here, and I think I might not be turning sharp enough angles. And so as you get closer, what's happening is he takes a step and ends up a little off, and I'm trying to adjust it as you're walking. Well, there's a little bit of issues with, oh, I didn't wait till the avatar built. But see, now he's going away from it, the target, and that's already an issue. Okay, let's see what happens. When he gets close, he stopped. That's a good sign. I expected him to be facing the wrong direction. The fact that he is not on the ground, I don't want to change Y position. I only want to change X and Z position. That was just a last minute bounce to position type thing. And absolute rotation. We're gonna work on what angle we want him to be on based on what we're doing. So let's knock those out of there for the moment. Oops. This is stuff that we'll end up using for some points, but let's see. When we get to the position, we're basically telling it to stop. That's when we clear the interval. Otherwise, we should be continually rotating, because that's all that's left to do is rotate. I need to check. That's my avatar degrees, and that's my target angle that I'm trying to hit. If the angle is here, direction 0, we're telling it to move by 1 angle degrees at a time. It's not allowing for fine tuning if it's very close. I may need to make this function right here where, depending on how far away you are, it may take a very much larger angle changes at a time. And then if you're really close to the direction, then it may be a lot less of a thing. Like the direction change, instead of being so major. Here's what we'll do. This is if you're facing it directly on, there's no direction change. If otherwise, we're going to copy that, and I'm going to say if it's less than if it's less than 2 degrees, I'm going to start moving in 0.5 increments. We'll try that first. And degree left equals target angle. That's fine. Okay. If it's... We're making 3 different concerns here. If it's less than 180 degrees, we move by 1 degree. I'm going to say if it's less than 90 degrees, then we move by 1. Well, that's going to still be, if I'm pretty close. If it's less than 30 degrees, move by 1. If we're... This is going to help us turn sharper to the angle. If we're less than 90 degrees, move by 5. No, let's move by 3. If we're less than that, we're going to move by 5 degrees for every cycle. That should point us at the target a little faster, but also allow a little less, you know, if it's less than 2, less than 2, okay, wait a minute, I want one smaller than that. If it's less than 1 degree, I want some incremental changes. Otherwise, we're actually going off target by adjusting the direction at all. So if it's less than 1 degree off, then this should be 0.1. Let's see how that does. Now we should be getting a little closer to walking up to that position. We can be more sharp at the beginning, but then less adjustments as we get closer. I think what was happening is we're targeting an area that's like a 2x2 cube. And what if we miss it by a little bit and we start to fall off, it's over adjusting and then walks right next to it. Well, then it goes, hey, you're like 300 degrees off. And then it continues on its way. Now, let's see if we can do this. Nope, I passed it up. See, I'm not turning sharp enough soon enough. I want to know which section I'm running into here as we go. So I'm going to tell it, first of all, we're going to make that 10 degrees. This one, 5 degrees. You know, I know we're closer than this. 30, let's make this less than 10 degrees. Then we start going 0.5. This one we go by 0.1. I don't know if we're happening soon enough. How often is this correcting? Maybe that's the problem. Oh, we're at 1/10 of a second. Okay, we're definitely 100th of a second. That's plenty of time to make these adjustments and go for the angle. Angle should be rotating very quickly. Negative 0.5 there. 1 at this degree to this degree. Okay, let's find out which section we're in. We're going to say section equals 0, which means we're pointing at the target. I need to see what's going on and see what section we're blowing this on. So section 1 degree, section 2 degrees. If it's spending most of the time and then missing the target, then I'll know what area it needs to be. This will help fine-tune it. Yeah, our angle isn't getting us there fast enough. I mean, I could spin it to the second you click it, it rotates to that angle and goes. But I think if I show the rotation, it's a little friendlier. But we also don't want to miss it if it's wrong. I may be doing this opposite, where I'm only changing it a slight amount when we get closer, when that needs to be more dramatic. Like if you are right there, you need to be able to rotate right to the point and get there. But let's check that first, and then we'll start checking the distance. And if the distance starts getting greater, maybe we can actually cancel the walking area so that it only rotates. Yeah, we'll have to check that. I'm trying to get it to hone in on it and be friendly for landing there. Okay, let's see what happens. Maybe the target where I'm trying to hit is, you know, I want it on the dot, but I'm trying to get it there by, yeah, I don't know. Let's see. When it's to a certain level and it gets that close, it's not showing me that number. Section 0. It moved to the center of the line. What? Now it moved to it. Oh, because I moved off the screen, it stopped. Okay, wait a minute. It moved to the point. We have something working right. We just didn't get it working right the whole time. If you move off this, it actually stops and idles, which I need to make some adjustments to if you're in an automated type thing. But we'll get that straight. That was the behavior I had before where, notice if I start walking and I move this off the screen, he goes to an idle position. That's just a functionality I did so that you're not like autopiloting him. So I decide, okay, I want to walk over there. Here it comes and stop. Hey, he landed there. Okay, let's practice that move. And let's go to a steeper angle. We can see that cube. Let's click here, which will start that process and get him walking over there. The rotation wasn't too bad. I think we rotated faster sooner, and he walked to the point. Hey, we're getting somewhere. Yay. Okay, so I think we're on target. And once we get there, the trick is to rotate towards the ball. That's the whole thing that we're aiming for, is to rotate to the ball. So let's see what we can do here. You know what? I'm going to create a function just like I did the walk to point. This one seems to be working better now. We were able to hit our target. So some of these stronger angles at a distance seem to affect it. If you're far off the target, we need a quick rotation to get you started. If you're closer to the target, then basically fine-tuning so that you don't pass it up. That's what was happening before, as I was passing up the target. So now that gets us to the point, and then I want to say rotate to angle. That way I know, hey, if I want to face 90 degrees or whatever, I should be able to tell it a function that gets it to a particular angle after the fact. I tell you what, I'm going to take a 5-minute break, and then I'll be right back with you. So I'm going to refill the cup, and I'll be back. So bear with me. Be right back. Hello, I'm back. Okay, so we've gotten it to walk to the position, which is a good sign. And next we need to rotate it to the direction so that they can address the ball. So we're gonna tell it, well, let's just test it one more time here first and see what we have to work with. And we're gonna go this direction, and he just passed it up again. See, that's what I'm worried about. Why is it that certain directions... Okay, if you're that far off, then there it is. Okay, that was a little round the block to get there, but I'm going to work on that. What it is, if it's too steep of an angle and you're close to the object, maybe I need to check the distance. If it's less than a certain distance, then jump to the angle. That's kind of... That might not be a bad idea. We'll work on something there. We're going to make sure that works. But okay, for now, I'm going to... Once we get to this position, what we want to do is we want to make sure that they completely get squared off to where they're going to golf. So it's going to need to rotate to a particular angle, which goes directly to the ball. Since we're doing basically a right-handed golfer at this time, later on that's an extension to go left-handed. But okay, so we're going to start by just saying, okay, we walk to position. When we finish that, what we want to do is we want to rotate to angle. So I'm going to create, I'm going to create something that looks a lot like this. And this one's going to be rotate to position. Yeah, I guess walk and turn. We can use turn because that's equivalent to walk. Turn to rotation. That would be appropriate words. So we walk to position and then turn to rotation. That makes sense. Okay, so we have this. We should tell it mold to match. We could do angle to face. Or mold to face. That would probably be better, because then if I did something like that, we can actually calculate the angle, and it's more likely we're going to be facing a particular thing when we get there than it is to just go to a random angle. If we need one that, if we need one that goes to something in particular afterwards, then we can always get that. We're not going to do mold to match. We're not matching the rotation, we're facing it. Mold to face. Is there any other use of that? Nope. Okay, so first thing we're going to do is we're going to figure out the angle, and we're going to tell him to bounce right to it so that we know he's hit that particular angle. I keep saying he. It's avatar. Male, female. I'm trying to be politically correct. So in this case, it's going to be mold to face. And absolute position would be our avatar. Well, we already know our avatar's position because that is world position. So that won't be an issue. We're going to mark out, we're going to build this little by little. I'm using this as a pattern, but that's not what we're going to be doing. So I'm going to remark out that whole thing all the way to there. Do I need this in there or not? No, we already had one of those there. Let's get that like that. Okay, so this one is, oh, that should have been included. And this one is if avatar is not blank, okay, is not null. Then mold to face. We're going to use this item here. We're going to find out the absolute position of the mold that we're trying to face, and then we're going to calculate the angle based on that. This is not going to help us. So based on that, we should be able to, I think we already have a function for this. Under common, it's oops, sorry. Find angle to point, I think is the name of the function. And yes, it is. Get my angle to point. Well, that sounds about as straightforward as we could possibly get, because my angle is always going to be my camera view. That's based on camera view. Get angle to point and then adjust it for that would be different. The camera view has a different focusing thing, so I don't want to base it on that. Even though it is, instead of using the camera position, I want to use the, so get angle to point, and it's going to be from the avatar to there. Well, we'll get that much. And come back here. Equals WalkTheWeb, this, and then we're going to put in the absolute position of this is going to be where we're facing, so it'll be absolute Z and X. And then my avatar, avatar here, and that will be avatar dot position X and avatar position Z. That should give us an angle, and there may be an adjustment on that angle because the avatars are actually 180 degrees out of phase, I think. We'll find out here. Okay, let's spit out that angle and just know what direction we have to go. Angle equals, I want to test it from a couple different positions and see what we have to deal with. So I'm going to take this and go in here. We're going to walk to the position, then we're going to tell it to do this function, but for now I'm actually blocking that, and we're going to do just this one so I can check the angle. Turn rotation, and it's going to be my avatar and golf ball. So we want to know the angle to the golf ball from where we're standing. Golf ball is an object right here. Okay, so we have a golf ball and we know that that's there. We're going to be turning the rotation to make sure that it faces the golf ball, no matter what angle and position I'm standing in. So we're going to double check that and see what happens. At this point, notice I'm not facing the golf ball, and we're going to, the angle is 160 degrees, which does not look right, which means that we're 180 degrees out of phase, which is what I expected. We're going to double check that, but notice when I check this common file, I was going 270 from the camera angle. Camera angle is 90 plus the 180. That explains it. Okay, so here, if I'm going to turn that angle, what I'm probably looking to rotate is angle equals get angle to point plus 180 degrees. I think that's going to be the right angle that I want to go to. And just to do it, we're going to take our avatar and we're going to face it whatever angle it says it is, just so we can find out. Rotation Y equals get radians of angle. And that should put us right there facing the ball. No matter where we stand, when we click that, we should get where we're facing the ball. Let's find out. Does it work? Let's wait till our guy shows up so we can see what he's actually doing. And we're 180 degrees out. Notice. No, actually, no, we're not. We are about 90 degrees out because we're facing this direction. So we're 90 degrees off. So since I angled 270 on that other thing with the camera view, let's find out if that's the same adjustment for this. There's a reason I'm testing this, as you can tell. Got to know the right angle that you want to hit so that when I start rotating him, he doesn't just keep going in circles. Make sure we know what our landing point is, and then we can work on getting it there. So from here, he is pointing this direction. That's not angle 430 degrees. That's not correct. Oh, it's a negative off. Watch this. If we say minus 270, so am I rotating the wrong direction? We're going to find out. That's why I'm doing all this. See, I might need to just subtract 90 degrees instead of add 270, but like I said, it's got to work from a bunch of different angles, so I got to check it from different rotations and see if... Nope, see, that one's wrong. That didn't do it. Okay. Get angle to point. Then from that point to that point, 270 degrees. Do we already know? This is why this particular thing always throws me off. I take two positions, I calculate the angle to the point, and then I do it, and I'm out of phase. I'm just curious. I'm going to make it work and then see if it works at different angles. So if I back off 90 degrees from the original, I want to see if it hits it. It's going to be a rounded number out of phase. I already know that from experience in working with this. So let's find out. Nope, see, it didn't face it. Now it's saying 70 degrees. I'm just curious. Is it negative 70 degrees to the ball? Gotta find out. Because I think 0, 0 is that direction. No, that's 180. We found that out on the other thing. That was 180. Okay, let's find out. And it's out of phase. That's not where we're aiming. Okay, I've tried that already. That didn't work. We're going to do this another way. I think it is calculating angle to point. The problem is I think the quadrants are reversed in a left-handed coordinate system, which is what's throwing me off. That's why this one never seems to get me the right angle. I know that's the correct angle, but the problem is we're facing the wrong way. Just thinking for a second. Let's try the other function and just see what we get. I'm curious. Get my angle to point. We're going to see what this gives me. If it's correct, I'm not going to fight it. I'm going to go with the one that works. Angle equals, get my angle to point, and I'm going to this point. And then I'm going to tell it to rotate and put me right at that point. And let's see if that aims where we think it's going to. If I already fixed this and already made it work, then there's no reason to reinvent the wheel and make it work again. Don't know why this has always been a little sore spot, but hey, I'm going to take it for what it's worth. If I click that, notice I'm not facing the item. I think I'm 180 degrees out of phase. So if I take that minus 180, I think my back is facing right to it. Told you there's something, when I went from camera views to working with avatars, trying to line 0, 0, 0 on the alignment on the angles ended up screwing up the avatars 180 degrees out of phase to work with the cameras. So either the cameras, because you're looking from behind it, were backwards 180 degrees from the position of the guy, or the guy was rotated 180 degrees out of phase. Don't remember which one I chose, but obviously there probably would have been an easier way. Now notice he's facing-ish the right direction, but that's not facing the ball. The ball would have to be in front of him over there, and it's over that direction to the side. That is not correct. That's why I run into so many problems trying to work with the avatar and get it to the position, because if I do this and click, yeah, see, he's always going to hit the same position. 140. Well, that one hit 147 degrees. Oh, get that out of the way. This one says, now see, I'm rotating an angle, but they're different positions every time. That's not helpful at all. Why is it giving me different angles? Oh, it's telling me to rotate a certain degrees to get to the position. That's why if I face it, it's wrong. It's actually the angle, the delta angle that I need to change. So if I take my rotation and I take the angle plus equals get degrees of that actual rotation and add it to it. That's why I wasn't accounting for the current position. This is an adjustment to my current position to tell me what angle it sits from where I'm at. So that's why it was dynamically changing as I rotated. Okay, I'm catching up with my own coding. Jeez. Well, I want you to remember this. I coded that line that determined that angle probably 4 years ago, 5 years ago. So now that I'm actually working with it, now see, I'm 180 degrees out of phase. I think. No, I'm facing this direction. Huh. Let me see. Oh, let me take angle plus, let's try minus my own angle. I'm going the opposite direction than I need to. And let's see. First, avatar loads. Well, it's not changing the angle this time. That's a start. That is possibly that distance out of phase. I think it's, well, let's see if I hit the same spot every time. Let me rotate this way. If I click the button, okay, I'm hitting the same position, which is a good sign, but because I subtracted off the degrees from the avatar rotation, what I need is to add the degrees from my negative rotation. That should rotate it the other direction off of center. I think I might be right on this one. And avatar loading. There it is. Nope, now I'm still off the same direction. That didn't do a thing. Okay. We need it to be, add both these together and then do a negative angle to reverse the grid. I think we're going to find out. Or we find the difference and reverse the angle rotation. I don't know. I could rotate the other way and it could be completely off again. Why do I feel like I'm just guessing now? There's nothing mathematical about what I'm doing. Now I'm off by that number of degrees on the other side. And I'm rotating. That's not right. Okay, so this here, it is the difference of the degrees the angle is there. Oh, that's showing me the different angle. Angle, and then I'm going to do the angle again after the delta angle, which is dangle. Okay, let's find out what the difference is here. Every once in a while I get stuck in an endless loop, and I feel like I'm on that right now. You spin me round, round, baby, ride round like a record, baby. Okay, now I'm completely off. 209 degrees, angle 360. If I rotate to a different angle, do I hit the same place? Or nope, I'm hitting a different place each time. Okay, so that is not correct. We need the negative angle to the one we're currently working on, and find out why this isn't working. The delta angle is giving me, okay, so 67 degrees, which is going that direction, and no matter where I rotate, am I going to hit 67 degrees again? Oh, it's a negative 67? No. 67 degrees and a negative 289, which is our same angle with a positive number. In here, I can do, there's a function for correct angle. I think. Clean angle, that's what it was. And what it's going to do is it's going to make it always a positive number just so we can see the number that we're going to. Actually, I don't even think. We'll do it that way just so that it's always a positive number. Not always a positive number. Yes, it is always a positive number, but it could be, yeah. Okay, so when I click this, oh, clean angle wasn't right. Is it clean degrees? Let me guess. Clean degrees, that's the one I'm looking for. When I clean the degrees, basically I'm looking for it to be within 0 to 3, less than 360. So that will automatically make it one of those numbers and allow us to spin in a full circle but always have the same measurement. So we're not comparing like 10 degrees to 370 degrees. Makes it easier to decide if you're at the right rotation or not. Okay, so 67 degrees, and if I go this way and click it, I'm still, 72 degrees. 67 degrees. 67 degrees. Why am I? Yeah, gotta get it in view. This way hits 72 degrees. That way did 62 degrees. Or 67 degrees. Why? Okay, that's another little fun. I think that's a rounded number issue maybe or something. I don't know. But 67, notice it's not the same angle. And every time I do it, it's changing. Why is it changing? It's off a little bit every time. Okay, well, that's where I'm at right now. That's what I'm going to work on, and it looks like I've got a little bit of work to go for figuring out a way to calculate the angle from wherever I'm standing to a particular position. I'm going to need to do some studying on that one and see if I can't correct the math here and create a function that makes it real easy for us to get in the future. Because for whatever reason, it's not playing friendly, to say the least, and I need to know, is it correct? Yeah. The fact that it's changing every time I check it is kind of worrisome because it's not saying this is the correct angle right now. This is saying, oh, it's somewhere around here, and it's kind of like giving me a rounded value. And if there's some rounding going on or if there's a float value, point value issue, I need to calculate those. I need to figure it out. But I can't get it to rotate to a position unless I actually know the rotate angle that it needs to go to. So yeah, we're gonna have to do some stuff to figure out. We're gonna have to figure out where that's at. So yeah, gonna do some studying. Gonna do a little bit of lookup on that and see if we can't calculate the right angle. Once we get that, then I think we're gonna use that function a lot from here on out. So it'll be very friendly to use and it'll be nice to have afterwards. Okay. So I want to thank everyone for watching me today, and I'll be back again real soon. I'm working our way through this. So far, we're able to walk to a position, and then we're going to rotate to it, and then we're going to work on some animations to actually do the golf swing. So that's the plan. That's what we're going to do, and we'll get there. We'll get there. Oh, funny, I walk farther away, and it angles. See, that's telling me my angle is completely off because there's something that it's not catching right, and I need to make sure that we're working in the same world grid. I need to make sure that we're trying to calculate the same angles and everything else. Till that's right, we're going to have issues with this particular function, so it's time to dig in on that. But thank you for watching. And I'll see you again real soon.